knowing how to do it, and now I don't remember how to do it.
And I strangely felt confident as I was taking it, probably because I've been like reviewing all the chapters and kind of rereading stuff. But that being said, I'm the queen of the dumb mistakes, so I wouldn't be surprised if I missed like every single one.
But just barely. You would have just barely.
Well, let me see if it let me on. I'm assuming the quiz online is the same as what we have in front of us, right?
It should be.
Nothing, just spinning. Oh, here we go. Here we go. Weird. I'll just be patient with it. Do you guys already have it open?
I'm
almost there.
Basically.
Okay. It's very time consuming to do these questions and to have to like open up the Excel data, copy and paste everything. Like,
oh, I know.
You know, like doing these 25 questions took me like 2 hours.
Oh.
I know,
and I just was like, I think this exam is going to take quite a bit more time than last time. Like last time we had 4 hours and I only used like an hour and a half. This time, if I'm slow and super cautious, I'm like, I could see it taking a lot longer.
Yeah.
I know.
Like I might be hitting that 3 hour, 4 hour time frame. So,
okay. Okay, we're live. Okay.
Now, I remember there are some questions on here that I just wasn't quite sure. I was doing this at like 11 o'clock last night, so I was not.
You had the brain burnout?
Yeah, pretty much. And so I feel like I just answered the question, even though I didn't fully understand it. So
well, then let's take our time right now and make sure you got it.
Okay. Sounds good to me.
Do you guys want to read it since I still don't even have it open? Like still spinning. Okay. I have what I have in front of me, but it just may not be the same.
It looks like it's all off by one question.
Yeah.
Oh, okay.
Yeah. Because the first question's like, did you participate? So number 2 is our number 1, which is given 90% confidence interval of 45 to 105 for mean heart rate. Which of the following is the best interpretation of this confidence interval?
Okay, yep, that's word for word the same. I put A for that.
That's what I put.
This is where I was confused, I think, because I thought it was we are 90% confident that the true mean heart rate is between 45 and 105. Because it's not of all people, it's just the people that were tested.
Well, you know what?
Or that were surveyed.
A on the quiz is different. It's actually B on the quiz. We are 90% confident that the true mean heart rate.
Oh, okay.
That's why. I put A on the preparation, so that's why I said A.
Yeah, me too. Sorry.
Okay, sorry. I wasn't looking at that. So is that what we think it is? We're 90% confident?
Yeah.
Mm-hmm.
Okay. And then there was, remember, I don't know if you guys remember this, on the last quiz we had, I got one of these wrong because the other like thing that it said was, the other option that I thought it was something like 90% of the data is in between 45 and 104.
Oh.
Remember that? And I got it wrong like both times.
Yeah.
But you know what I'm talking about?
I got that one wrong too. I remember what quiz you're talking about.
Yeah.
I got that wrong too.
Chances are very good I got it wrong.
And I remember in the reading, I honestly can't remember where, but I remember in the reading that it uses the wording, we are this much % confident that the true mean is this.
So it always starts with those words, and then from that point on, who knows?
Yeah, that's true. Okay, because it said like, what's the second best way you could write this out, or something like that. And that's the second best way, like, didn't say that, so that's why I was like, I don't know.
Strange. Yeah.
Okay.
You guys, I've tried to get on 3 times. It's like something with the BYU Idaho website on my computer right now.
That's so frustrating.
Have you
It's like
tried using different?
I'm streaming on YouTube right now and it's fine.
Have you tried different browsers?
No, I always use Chrome, but I will try using something else now. I'll try Internet Explorer. Weird.
That's weird.
Luckily, I printed it out so I can still work with you guys.
Okay, the third question is the same. The University of Mississippi one.
Yep. Did you guys put B? I put B.
Preparation. Yes, the distribution of the mean of each sample is normal since the data have been determined to be normal. Yeah.
Yeah, that's what
I
put.
wasn't sure about that one though. I was like, ooh, that's one of those tricky ones that my gut's telling me it's B, but it could be something else.
I think if it wouldn't have said that they looked at the QQ plot, then it would have been no because the sample size is too small.
Right.
Okay. Okay.
So
I'll make
because
a
they
note of that.
specifically said that the Q plot was normal, then it doesn't matter what the sample size is.
Okay.
The next one. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
I put D, but
So I don't know what D is because I think they're all different on here.
Different orders now.
confidence interval for the difference of means using independent samples, not dependent samples.
Yeah, that's what I thought it was.
Because they're random females and males. It's not husbands and wives.
Yeah.
If it's husbands and wives, it would be dependent, right?
Right.
Okay, so it'd be D or whatever.
Or if it's even like the same people.
Okay, yeah.
But it also gives you a clue because it says in the original information, it says that they're determining if the difference of the means is significant, and then in that it says the difference of means, and the other one says mean of differences. So I think like a lot of them give you little clues inside of it.
Like so if it says difference of means, then that's where it's going to have the third column and you're going to subtract.
Right.
Mm-hmm.
Or is that wrong?
No, that's right. Because then the difference of the means, so yeah, you take the means and you figure out the differences.
Okay. If it says the mean of differences, then it's just 2 columns in that Excel spreadsheet, right?
Right. Then you take the mean of both columns.
Okay. Yep.
Yeah.
Yep. Okay, cool. That's a neat little phrase. I'm going to write that on my notes.
Yeah, that was helpful when I realized that.
Really smart. I didn't even think about that until you mentioned it, Marion.
Well, look at me. Maybe I'll get an A.
Oh, girl, I feel it coming your way.
I'm gonna get an A. The next one took me a really long time because I kept typing in the wrong. I highlighted the wrong thing on the normal probability applet, so my z-score was off.
I didn't calculate anything with this one. I just thought if you have a bigger N, your margin of error becomes smaller. So I put B.
That's what I put on the, so yeah, on the quiz it would be D.
Obtain the balances of 90
Sorry, I mean, I thought we were
rather than 30.
the question. Yeah, I think I'm talking about the next question on accident.
Oh, okay.
Yeah, that's what I put too.
So you put B too, okay.
Yes, because yeah, because that would make a difference. That's the only thing.
Yeah, at first I circled C, but then I realized those numbers would have to be reversed for that to be true, right? It would have to be like compute a 97% confidence interval rather than a 95. Oh wait, no, that's still the same thing.
A 90%, yeah.
Yeah, like the confidence interval would have to be smaller, right?
Right, yeah.
Not bigger.
Yeah.
Okay. That's what I'm trying to say. I'm still not getting on this either. This is bizarre.
Oh, I'm so sorry. That's so
bizarre. I'll just have to do it later. I probably just need to like Control Alt Delete my computer right now. You know?
Yeah.
It's just weird because obviously my internet's working on a Google Hangout.
Yeah.
Yeah.
Weird. Okay, for 5, I got A on here. It's like 998.040.
Yeah, so the margin of error would be 1.64, right?
Wait, but it's not asking for the margin of error. Oh, are we on number 5? Oh, sorry. I'm on the one that says a factory makes propeller drive shafts.
Yeah, on the test it asks.
Oh, it's not asking for the confidence interval.
It does afterwards.
Weird.
Yeah, margin of error. Okay, so what is the margin of error?
I think it's 1.645. That's what I found earlier. I mean, to find the confidence interval. And then what did you find for your confidence interval, Lindsay?
I picked A, 998.040, that one. And then 1001.96. Is that what you got, Josh? Josh, did you freeze?
No, I did. I got the 998.355, but I didn't calculate anything. I was just that was one of the ones that I was just like, oh, let's just pick one.
Hold on, I've got a parent here to pick up a kid.
Okay.
Roman, your dad's here. Hello, how are you? How was the day?
You made me a picture?
That's nice.
That's excellent.
I think that was right?
I guess.
Well, you sat in front of a cheeseburger that I bought for you and ate up something. Oh. And then, see you Monday. Have fun. Have fun together. It's so nice outside. Bye, guys. All right, what number are you guys on?
We're still on the same one. Mary Rose, I think she's joining the call again.
You know what? My picture of you guys has frozen, but the sound hasn't.
Oh, really?
So obviously my computer is seriously struggling. Maybe if I click on it, it will come back to life. Oh yeah, it's alive now.
Okay. I have a question. I can't remember. What is the margin of error formula?
Dude, this is the greatest question ever.
I feel like
I have no lie. In my notes, I have 3 different formulas written down for margin of error. I'm not kidding.
Oh.
I'm like, and that is the question on the quiz that I keep missing every single time. So I have written down that it is,
Oh, there I am. Wow. That's weird.
Hi.
Okay.
Hey, Maren.
I could hear you guys and I was like, I have it. And you guys are like, blah, 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 blah. And I'm like, can they not hear me?
Oh, that's funny. Josh just asked me what the formula is for margin of error. And I said, after I have gone through all my notes this week, I now have 3 different formulas written down for margin of error. And I'm obviously super confused about it because it's the question on the quiz that I have gotten wrong every single week.
Oh, no.
So what do you think the margin
of
error is?
I just had to write it. I had to go back in the notes and find in the reading and find it because I didn't remember either.
What do you have?
It's m equals z times sigma over the square root of n.
Okay, that's what I have too. Or it's t times sigma over the square root of n.
So that's one of them. That's one of them.
So that's two. Z or t, it's the same thing. And then if they ask for the margin of error and they give you the two confidence intervals, you have to take the lower first, minus the upper, divide by 2, and that's your answer. Or
I don't think you have to divide by 2.
Or you subtract the upper limit from the mean. All of those things give you the margin of error at different times, and I'm not quite sure if I understand when to use them.
Well, I think there's some questions about that, so that's one part that makes sense to me, so I can try to explain it to you when we have those questions.
Okay.
So for this question of margin of error, what would that one be?
It's the z-score times the sigma over the square root of n.
Times sigma, which is 2,
Mm-hmm.
over the square root of n, and n is 4, looks like.
Yeah.
And Maren, should that be our positive z-score, not our negative z-score, right?
Well, it doesn't really matter because, I mean, this one turns out to be positive, but
is margin of error always positive?
Yeah. Well, yeah.
Okay, that's what I wrote down in my notes. Is margin of error is always positive. So,
but it's like that's the number that you subtract or add to the mean to find the confidence interval.
Yes.
So it's not like one of them is negative, and it's not like it's always positive because it just depends what you're using it for.
Right.
Gotcha.
So then the answer to this one would be 1.96.
No.
I have 1.64.
1.64.
So the z-score is 1.64 because that's what 95.95 gives you. Right?
Oh, I thought it was 1.96 that it gave you.
Yeah, that's what I have. 1.96.
When I just did it, it did that. That's weird. Okay, let me double check.
2 over the square root of 4 is 2 over 2, which is 1. So Josh is right. The margin of error should be 1.96. Right?
I think so, yeah. 1.64, I think, is for the 90% confidence interval.
Yeah.
When I type in 0.95 into the normal probability applet, it gives me 1.64.
Okay,
wait, what do you have to highlight? Do you have to highlight the middle?
The middle, yeah.
Okay, that makes a difference then. Yes, you're right. That's where I kept this one. Okay.
I did that too, Maren, and I was so confused. I'm like, I don't understand. I have the area at the top of my normal probability applet set at 0.95, and the answer isn't 1.96. I did that same thing. And I was
okay, then you were right. You got the answer right then. I think you got 998.04, right, as your low one?
Yep. And then 1001.96 for the upper.
Okay, you did it right.
Sweet.
Good job.
So far I've gotten 100%, you guys.
Good job. So that means our margin of 0.96.
Yeah.
Okay. Yeah, that's the one I had to keep, like, I couldn't figure out what the z-score was, so I'm glad that's what I was doing wrong.
I'm trying to hop on again. Here we go. Come on, baby. I'm showing like full bars. What is happening?
Okay, so this will probably make me be able to do question 9, which is your question 8, Lindsay. Because I was not able to figure this out, but it's probably just because I had the wrong.
You guys, I'm on. It's working.
Oh, good.
Okay,
Yeah, let us know when you get to the quiz. What?
Oh, I was going to say, what did you get for 6?
I got 38416.
That's what I got.
Too. Okay. Sweet. And then for 7?
I haven't done 7 yet.
I got the first one, A, but I know that it's probably different on the quiz, which I'm actually opening right now. Sweet.
Yeah, that's the one I got. So it should be D on the quiz.
Okay. And then for 8, what did you put?
I put B.
I put D, but I really was not sure about that one. Like the wording on it was super confusing. And as I circled it, I was like, I really don't understand this one. So you put.
I'm sorry. Can you guys explain to me number 10?
Yeah. So the question asks, the mean area U of the several thousand apartments in the new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. So that part right there is what you want to look for.
Awesome.
They make their new hypothesis saying that it's smaller than the mean.
So the null is going to be that they're equal?
Yeah, so the null is that U equals 1250, and then the alternative is U is less than 1250.
Okay, that makes sense. Thanks.
Mhm.
We reject the null hypothesis with the level of significance. If it's low, so if the p-value is less than A, so B on the test.
You put B too? Okay. What does B on the test say?
P-value is
less than
A. Okay, I had that opposite. I'm almost caught up to you guys on here.
The question on the preparation was different than the question on the quiz, just by a little bit. Like the wording was different. On the preparation, it says in a statistical test of hypotheses, we say the test result is statistically significant at the level of significance if, and then the answers. That makes it really confusing.
That does make it really confusing. Goodness gracious.
So the way that quiz words it is a lot better. It says we say we reject the null hypothesis with the level of significance alpha if, and then gives you the options.
Oh, weird.
Oh, the wording on these. Curse it.
Yeah.
A group of statistics students want to determine if students in some apartment buildings get better grades than students in other buildings. They collect GPAs from anonymous random sample size of 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use a ANOVA hypothesis test to answer their question?
I said yes.
I said yes too.
So
because it's 4 different, so it's more than 2 means.
I said, yes, it is enough that the data are bell-shaped with no outliers and the sample standard deviations are nearly equal.
Yeah, that's what I thought.
What did we just learn that was the opposite of bell-shaped? Like, wasn't there one that we just learned that was like, these are not bell-shaped? Was that not ANOVA?
Oh, where it's like right-tailed or left-tailed?
Yeah.
So
they're still bell-shaped though.
Yeah, each individual set of data is bell-shaped, but the overall, like the F statistic graph is not bell-shaped. It's right skewed.
Okay.
Which is weird.
That's very confusing. Good question, Maren.
Okay. Oh, these ones, I
Oh,
know
yeah,
I'm on the test.
Sorry, I'm almost there.
you're good.
So for your guys' 11, you put B, the p-value is less than A.
Yeah.
And then 12 was yes. Okay.
13.
Or at least that's what we think.
Yeah.
Okay, for the next one, I put committed a type 1 error.
I just haven't memorized these yet. I don't really understand it very
You
well.
don't have to memorize it. Just write it on your sheet of paper for the exam.
That's true.
I put committed a type 2 error, but I honestly can't really remember what the difference is.
I have it written down right here. A type 1 error is when we reject a true null hypothesis. A type 2 error is when we fail to reject a null hypothesis that is true. So the null hypothesis would be rejected. So she rejects the null hypothesis.
She rejects the null hypothesis.
But in the future, it is determined that the new treatment does not increase the mean survival. So what was the null hypothesis again? Is that the average survival time after diagnosis is the same. So she's saying it's not the same. When she rejects it, the null hypothesis is saying it's the same. When she rejects it, she's saying it's not the same, right?
Right. So the null is true, and she said that it wasn't.
So the null is true. Okay, we just talked through that. So the type 1 error, again, is when we reject a true new null hypothesis.
Okay.
So I think the answer is type 1 error, but the wording from the textbook for type 2 error is we fail to reject the null hypothesis that is not true. Oh, so it wouldn't be that because we know the null hypothesis was true.
Right.
Oh, that hurt my head.
No, it made sense when you walked through it though.
That does make sense.
So that's what we need to do on the quiz is we need to be like, okay, the null hypothesis is this. They're saying it's this, but then later in the future they find out that it's this. What's happening?
You just need to find out what happened to the null. Like, is the null actually true or false, and then go from there.
Yeah. So I think I was right with my committed a type 1 error.
I think you're right too.
The next one's similar. If A is made very small, therefore making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
I'm almost positive it's D. By reducing, well, on here it's not D. By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah, I remember that one from the reading.
I have it written on my notes because I knew that would confuse me on the exam.
Because it makes one wouldn't reduce the other because that doesn't make sense. Because then nobody would ever
commit an error.
Yeah,
Okay, the next one you kind of got to go through everything. Like you got to figure out the z-score and then input the z-score into the normal probability app. Is that right? Is that what you did, Josh?
Yeah.
I'm going to have to go through and do it because I haven't done that one yet.
Oh, and Josh, this is the one that I was confused. Because I got the z-score of 1.76. Which isn't that the z-score for a 90% p-value?
90% is 1.64.
Oh, so then I was confused because then it was still at 0.05 level of significance.
Oh.
I think I get confused because when they give me the level of significance, I automatically assume that the p-value is 95%, but that's That's the level of confidence, right?
Yeah, so 0.05 is level of significance, so it would mean 95% confidence interval.
Okay. And I keep confusing the confidence interval with the p-value, and that is not the same thing. So when I did this problem, I was like so confused because I was confusing those two, you know?
Yeah, that makes sense.
I got for this one D, we reject the null hypothesis.
That's what I got.
Because I got the z-score is 1.76. I entered that in the normal probability app. And it gave me the p-value of 0.025, which is less than 0.05.
Did you get 1 point? You got 0.176?
No, I got 1.76.
Okay, I'm getting something different. Did you subtract?
It's very possible. I have very scribbled notes that I'm looking at.
No, I'm sure you did it right because I'm just like trying to go from memory. And I never remember which mean to subtract from which mean.
You do the population mean last, I think, right?
Yeah, it's 1.53 minus 1.5 over 0.17 divided by the square root of 100. Is that what you did?
No, I didn't think you had to do the square root of 100 to get the z-score.
Yeah, you need to do, because it's a sample size of 100.
Oh, okay. Okay. Could one of you tell me the formula for that? So it's x subtract 0 u.
Right.
Yep. Over standard deviation sigma divided by square root of n. So Josh, when you did that, did you end up with 0.0250 is less than 0.05?
I got to put it in here again, 1 point.
Because I have two things written down, which means I was obviously confused. I also have 0.0392 is less than 0.05. So I was obviously confused somewhere.
I got a p-value of 0.0388.
I'm sorry, I went to go get water. What do you have?
Good. I got a p-value of 0.0388.
Okay.
You still reject it, but
yeah, you still and that's what I wrote. I either have this one is less than 0.05 or another one is less than 0.05, so you still reject it. So what did I do wrong? Oh, I bet I highlighted the wrong thing on the normal probability app.
It could be. You have to make sure you do
the right
side.
But your z-score was 1.76, right?
Oh yeah, I did 1.764.
Okay. And then to the right, a 1.764. Okay, I rounded to 2. Okay.
I think it could be 1.765, but.
No.
Okay, so 0.0389. Okay, I got that.
I have 0.9223 for my z-score. I mean, for my area.
What part is highlighted?
The middle.
So on this one, you want to make sure you highlight the right side, because the alternative hypothesis they're testing is that the mean is greater than.
Oh.
Maren, I missed that too. That's why I got mine wrong.
Okay, so then.
The good news is either way, your answer is still going to be you reject the null hypothesis on that one.
Okay, because it's less than.
Uh-oh, did I close my quiz out? I'm an idiot.
Oh, because it's less than 0.5. 0.05, so reject the null.
Mhm.
Okay, wow, that took a long time for me to do.
That's okay. I had it wrong too, and now we understand it better. Oh my gosh, you guys, I think I just closed out of the dumb quiz.
Oh no.
Ah, kill me now. Maybe it's saved. When I opened the normal probability applet, I shut the quiz down.
Oh, shoot.
Oh, I'm so sorry.
Sometimes I feel so mentally impaired. Ah, goodness gracious. Okay, yes, I hope I did save all the questions. What about for the next one? What did you guys get?
I haven't done like the next
Oh,
4.
that's right.
So
This one, on one of these, I worked through the whole problem and then didn't get the correct answer. So then I went back and tried it on the other one. Like I kept getting confused with the dependent and the independent sample tests. Do you know what I mean?
Right.
And I can't remember which problem it was, but I worked through the whole thing and then didn't get any answers that were on the test. So then I knew I had to go back and switch the first question, which was asking you what the test was.
Right, yeah.
So on my note page, I made a ton of notes about that. I was like, like it's gonna be this if it's post-test, pre-test, husband, wife. Like I was like crazy specific on my notes because obviously I really get confused easily.
it is tricky.
I'm like, geez,
I think it's independent sample tests.
All right, it saved everything. Score!
Number of hours worked for wages per week by male students and female students.
I chose independent samples test, but I can't remember if it was the one I got wrong or not.
You like a random sample of 100 for each group and test if those means are different. I think it's independent as well. I don't know why I put one sample t-test. There's obviously 2 samples here, but it was
You were tired.
It was really late last night. Independent.
We're all losing our steam. Well,
I'm sorry. Somebody came to my door again. I got too many distractions. Okay, so Josh, you put what?
Well, I put one sample t-test, but that was really dumb because there's 2 samples there at least, so that's definitely not that one.
I put independent samples test.
Yeah, that sounds about right.
Because they're not husband and wife. And it could be any males and it could be any females, right?
Yeah.
And the males chosen for this, they don't depend on each other. Like because you chose one guy doesn't mean you have to choose the other girl.
Right.
Exactly.
It would be independent.
So when I say it out loud, I feel like I understand those 2, but like I said, I kept choosing the wrong thing. So whatever.
That one's hard.
So for 17, this one is brothers and sisters.
An educator is interested in academic.
Uh-oh, I lost you.
You're a loser.
You're there still, Josh, but she's gone.
Yeah.
Maren, are you there?
You can. Yes, I'm here.
Okay, we couldn't hear you again. That's weird.
Oh, sorry. I wonder what's happening.
I was like, she's gone. We lost her.
I think it's got to be the dependent sampling.
Because they do depend on each other. And I put D, I put dependent sampling. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study. So they depend on each other. Is that the one that you guys put?
Yeah, because the other one doesn't make sense. Like the other dependent one
doesn't really make sense.
Like a sister can be good at something that a brother is bad at.
Yeah. That doesn't have anything to do with what we're talking about.
Yeah.
That looks good to me.
A soil
That's one
scientist
I have
collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Dissolved organic carbon molecules are an important part of an ecosystem and help plants to process organic compounds. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Open the data file. Use this information to answer questions. So I opened it first before I did this because I wanted to see if there was like 2 columns, 3 columns of information. There was
Right.
1 column of information. And then I reread the problem and it doesn't tell us about the sigma, like what the sigma is.
Yeah.
So I chose confidence interval for the population mean when sigma is unknown.
That's what I did.
If it was mean of differences or difference of means, it would be a 2-columned thing of data, right?
Right.
Okay.
And if it was when the sigma is known, they would have had like a population mean and everything else in there too.
Of the data, or in the word problem above.
Or yeah, yep.
Okay, yeah, that was my thought process. I just thought I would walk you through it to see
So
if
they
I
just like didn't give us
something
enough
else.
information.
Yeah.
So it's A.
Yes. But I think you can figure out but like when I put it in, it has there is a confidence interval.
Yeah, there's going to be a confidence interval and there's going to be a mean, but they're not giving us like sigma's the population mean. They're not giving us the population mean.
Or the standard deviation for the population.
Okay.
Like, yeah, we can plug it into Excel and get a mean of the samples, but no population mean. Does that make sense, Marin?
Yeah.
Okay. This one, I got a confidence interval was on the piece of paper, but I didn't do the margin of error because it wasn't on the margin of error. What does your confidence interval say, Marin? Are you entering it right now?
Yeah, so my confidence interval is 11.168.
Lower and then upper 15.217?
Yes.
Score, that's what I got.
But to find the margin of error.
Yeah, I'm going to be lazy and I'm not going to input all of this in again because I did this last night. You know what I'm saying? So I'm just going to go with what you tell me for the margin of error.
Okay.
For the margin of error questions with this, on the quiz, I kept putting that whole standard margin of error square that they have on there, and that's not the correct answer. So on the quiz, we've got to like figure it, I mean, on the exam, we have to like figure out the margin of error from the formula, right?
No, because since it's given you the confidence interval, you just subtract both of them from the mean.
Okay. Yep, that's what I have.
And both of those are the same answers, which is 2.025. Is that what you guys think?
That's what I think.
I'm doing it right now to make sure that I understand this.
So you just take the mean and you you take the mean and you subtract the lower and then you subtract the higher into individual problems to make sure you get the same answer.
So what did you get?
The same answer, 2.025.
Yep, that's what I got too. 2.025. However, I did it a different way. I did lower confidence level minus upper confidence level divide by 2, and it gives you the same answer.
Probably like that's probably the real way to do it. I just was doing it. I was like making up my own formula, trying to figure out.
Well, it works. Both ways work. I just kept getting it wrong on my quiz, so I called my friend who's up the street in the same exact class, but a different professor. And that's the way she learned how to do it from her professor. Because she emailed her professor and said, this margin of error stuff is so dang annoying and no one in my group understands it. And this is what he told her to do.
So you did 15, subtract 11.
I like typing into my calculator, I put 11.168 minus 15.217 equals, take that answer, divide it by 2, and that's 2.025.
Okay, cool.
And then the last step, she told me, like I wrote down her steps. She said, if your answer is negative, change it to a positive because margin of error is always positive.
Okay, that makes sense.
Both ways work, you know?
That's cool.
But that just came from her. Which once again, super confusing because it's completely different than the margin of error formula that we were doing earlier.
Yeah.
So if we take the margin of error formula that we had earlier, the z times what? Standard deviation divided by square root of n, do we get that same answer, do you think?
I don't think so because
I don't think so because that's what I was doing on the quizzes and getting it wrong. But maybe I was just typing it in wrong. So confusing.
Yeah, I don't think the margin of error formula will work for anything that has more than has two samples or more. I think that only works for if you have one sample.
Oh, interesting. So if it has more than one sample, we need to use the confidence intervals to find the margin of error, correct?
Mm-hmm.
Okay, that makes sense. Because she told me she did it this way on the quiz and she got the answers right. And I'm like, oh, this is so frustrating. Ready to move
I'm
on?
plugging the info in for the next thing just so I can go through it.
Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? I put confidence interval for the difference of means using independent samples. Oh, but I think this is the one, Josh and Marin, that I did and got everything wrong.
Okay. Well, I'll go through it and check.
So it might be the confidence interval test for the mean of differences using dependent samples.
Wait, how do you know you got them wrong?
Because my Excel spreadsheet didn't have any of the same numbers that were in any of these answer groups.
Oh.
Like I did something wrong. Like I copy and pasted only half the information or something. But I didn't really, I mean, maybe I did go back and fix it.
I put the same answer you did. I'm honestly not too sure though.
It was kind of confusing because it's similar information, but do the Hummers in group 1 depend on the Hummers in group 2? They don't. So it should be independent samples.
Yeah, I think it's independent samples.
And for 18, did you get for the confidence intervals -423 and 5417?
That's what I got.
For what?
Okay. So this is, I did do this one right, which means it's the next one that I did wrong.
Okay, I think I'm lost. Are you guys are talking about the confidence intervals?
Yeah, the confidence interval. That's just the next question.
Yeah, that was the next question on the preparation.
But on this one, is it asking for margin of error again?
No.
So 22.
Oh, 22, yeah.
For number 22
should be C.
So confidence intervals for the difference of means?
Yep, yeah, using independent samples.
Okay.
Is what we're pretty sure about.
And what did you guys get for your lower bound?
-423. Is that what you got?
Yeah, 238.
And then 5417 for the upper.
And are you adding your decimals?
On the, we probably should on this, on the homework, like it didn't have decimals. So you tell us what the decimals are, Marin.
The lower is 0.238 and the higher is 0.336.
Okay.
I gotta take a minute and get my kids ready for piano. 1 second. Read the next problem. Guys, you need to turn this show off, get your shoes on, get your piano book collected. Okay, show off.
Okay, I'm gonna open it.
Boys, get ready for piano. Go to the bathroom, grab a snack, get your piano book. Shoes on.
So
All
this
right.
is a Nova.
Yes, that's what I put. And for the test statistic, I got 7.978.
That's what I got.
Sorry, I'm not there yet.
You are fine. Give the p-value. I got 0.002. Is that what you got, Josh?
Yeah, that's what I got.
Marin, I'm going to just run through my questions with Josh really fast.
Okay.
Because I got to go.
Okay.
The next one, Josh, that said like with which of the following best expresses the conclusion of this test?
Yeah.
I put there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups. Is that what you put?
That's what I put.
Okay.
Okay.
And then this is the one that I have scribbles over everything.
This one I put dependent sample test.
Okay. Yep. That I scribbled out independent and then put dependent. So that's the one that I obviously did wrong the first time and then got. And then for the test statistic, did you get 1.685?
Yeah. P-value 0.096.
Yep. Yep, this is the one that I put everything down wrong, and then I was like, And then the last question is, there is sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days?
That's what I did, yep.
Okay, score. Okay, I have to take my kids to piano, so I'm gonna stop this and then I'll post it when I get back from piano.
Okay.
Marin, you can finish with Josh. I'm sorry, guys.
Okay, you're good.
Will you shoot me a text and let me know which ones we missed? Like, will you jot it down and let me know which ones we missed so that I make sure I study them correctly for the exam?
Yeah, I will.
Oh, or here, hello, I'm submitting it right now and I can tell you guys. Please do not have a whole bunch wrong. Because if we don't have a whole bunch wrong, I only missed one. Like, what I had done was only one off from what you guys had.
That's awesome.
So, okay, number 8. We missed number 8, which is weird because it's an upper bound. Maybe I just typed it in wrong.
What'd you put?
I put, sorry, I scrolled 100.96.
Oh, it's 1001.
Oh, I'm telling you, I am the queen of the dumb errors. I do that every time, and you guys are like, you just typed it in wrong. One, okay, right. We're doing awesome. Guys, we're gonna do good on the exam. If it's like this, we're gonna do good on the exam. So we got a 29.5 out of 30 right, a 98.33. So you guys will get 100.
Great.
Yay for us. I'm so happy. Okay, yay. I feel like I can, maybe study a little bit more tonight and then just take the exam Friday and be done.
That sounds like a good plan.
Then I can just focus on Excel. Sorry, I have to run. I'm going to stop the broadcast. I'm sorry. Good luck on the exam.
Thank you. We'll see you later.
Sorry, Marion. I didn't mean to rush you.
No, you're good.
Okay. Bye, guys.
Yeah.